Thank you for joining me for this Mentor Graphics sponsored Connecting Medical Devices Securely Over Wi-Fi in Hospitals webinar. My name is David Niewolny. I'm a Healthcare Business Development Manager with Freescale Semiconductor, and I'm going to be telling you a little bit about healthcare connectivity, talking about the Internet of Things, how it applies to healthcare, and actually just start talking a little bit about some design considerations, both from a microcontroller and microprocessor standpoint, which is really where I'm going to be coming from. And then we also have our partners, Silex, talking about some of the wireless connectivity, specifically Wi-Fi. And then Mentor will close out this webinar discussing the real-time operating systems, and hopefully we have some time for Q&A as well. So just some quick background on myself. I've been with Freescale Semiconductor for 14 years, so very familiar with the semiconductor, specifically microcontroller, microprocessor business. But then the last 7 I've really been focused almost solely on medical electronics. And the last 3, it seems like connectivity and wireless connectivity is a key piece of that. So very familiar with this market space and look forward to sharing you a little bit with what I've seen in terms of overall market trends. So the first thing is looking at the Internet of Things and connectivity. You know, everybody's talking about all these end sensor nodes that are going to be connected in building automation, smart cities, also in the space of telemetry. Smart grids is another key area where you essentially have all of these very low power wireless sensors connecting back to some sort of data aggregation device and then up to the cloud. And the last one I think that gets mentioned very, very frequently is industrial automation. One segment that seems to be forgotten is healthcare. And arguably this segment has the most to gain from connectivity and the Internet of Things. It's this connectivity that's going to drive things like remote patient care and drive the adoption of preventive medicine. Throughout the rest of this webinar, I'm going to discuss how the Internet of Things applies to healthcare delivery and the communication protocols that are going to be used in this particular implementation. And you'll see that Wi-Fi has a big part in that implementation. So next, just talk about the overall building blocks of the Internet of Things. And I mentioned, you know, on the first slide, talking a little bit about sensing nodes, smart devices, and then you have some form of connectivity. So you have all these sensing nodes and they need to essentially get the data to the cloud. How are they going to do it? And one of the ways that we see this happening is having a low power connectivity node to some sort of embedded processing unit. Then you have another piece of connectivity that gets that data to the cloud. And the end result is you have applications where you have a great user interface that you know, everybody can use. And in this case it'd be, as I mentioned, doctors, nurses, loved ones, and anyone else who needs to have access to the data. But then I think another key area is all of the big data analysis that can be done. Once we start monitoring ourselves in real time, I think there's really a huge opportunity in that space specifically. So looking at this from a kind of product or box level point of view, where are all of these connectivity nodes? Where is the embedded processing being done? From the first standpoint, you look at the sensor nodes or the products at the very edge of the network. Then you have your data aggregation piece, and with that you have some of the devices that I'm showing kind of in the lower center of the screen. It may be something like a router, a tablet, or I think in the case of a specific hospital you have something like a patient monitor, maybe even a hospital bed, but something that really travels around with that patient. It's per patient, but essentially it can aggregate all of the data from these edge products, which may be sensors like a pulse ox sensor, a ECG sensor. So you have this low power wireless, which I'll talk a little bit about some of those protocols earlier in your body area network or personal area network. And these are, you know, your low power wireless connections. And within that it connects back to your patient monitor. But then the next piece is, you know, how do you aggregate all the data within the hospital, within a home? You know, in the case of a home, it may be, as I mentioned here, a smartphone or tablet, where then cellularly you can transmit the data directly to the cloud. In a hospital setting, it may be something more along the lines of a Wi-Fi router that essentially takes that data then and sends it to another wireless device that then may be hardwired via standard LAN connection, and then you get to the cloud that way. And again, I think the goal is to have key applications where you can actually use the data and make sense of all of this data analysis. So looking at this a little bit further, and I kind of described this scenario a second ago, but it at least lets you have a picture of what these data aggregation devices specifically are. Medical connectivity, whether clinical or personal care, it is being done in both a hospital and a home setting. So having something like a home health hub or a gateway, I kind of gave two scenarios here. I mean, that may be a box, a router within your home, but it very well could be a smartphone or tablet, because that's something you do have with your have on you or with you a majority of the time. In a hospital or clinical setting, it becomes a little bit more complex. You're essentially going to have one hub per patient, and then with that you might talk to another hub that is more of a floor level or gateway, and then you might have one large data aggregation device specifically for the hospital. And that's really, I think, where we're talking a lot about the Wi-Fi connectivity, the Wi-Fi between the patient hub to the floor level hub, from the floor level hub up to the overall hospital gateway, and then you have your either wired connection or potentially cellular connection up to the cloud at that point. So the next slide that I'd like to talk about is really going into what do some of these gateways look like. So I showed you a actual gateway that looked very similar to your Wi-Fi router, and in a lot of ways it is, but the key here is this isn't just Wi-Fi to a LAN connection. This is taking in many wireless communication protocols, and that's because I think in this particular time that we're in, we don't have clearly defined standards for the healthcare market. There's a lot of standards, I think, competing for attention here, and actually in many cases a lot of them have their own merits, and I'll discuss that a little bit further in a second. But for now, looking at this gateway, you essentially have a Freescale i.MX powered gateway. It's currently powered by an i.MX 28, and this is a reference design that we have. But surrounding that, you have Bluetooth, you have Bluetooth Low Energy, USB for a wired protocol, Ethernet for a wired protocol. You have Zigbee with a healthcare profile on top of it. And essentially all of these particular wireless protocols could be used in a medical device. So the goal here is something that you would use in either a clinic or in a home environment where no matter what device is in that room, and these would be called kind of the sensor node devices, they would all connect seamlessly back to this device. It could potentially have some intelligence in it, but for all practical purposes, this is really just a data aggregation device that sends the data up to the cloud. The next potential device that I want to talk about here is a patient monitoring example. So this would be something you'd probably see much more in a clinic, or a clinic or a hospital. You don't want to have yet another box within the hospital environment, and for a period of time you may see these boxes per patient. But with that, I think integration into something like a patient monitor. You already have a patient monitor in every room. These tend to have wireless connectivity today. Just really putting some more wireless connectivity, so this product can essentially be a data aggregation device. You now have wireless sensors on the patient. This data gets transmitted through a low power wireless protocol to the patient monitor, and then the patient monitor can then use Wi-Fi or a LAN connection to connect essentially to the hospital network. So you can see wireless communications becoming very key in these particular devices, and really turning this device not only into a essentially one-way communication, which it is today, a patient monitor Wi-Fi connected to the hospital network, having both low power, low data rate connections really makes this a great hub of sorts, and saves from another piece of equipment in a hospital environment. So what exactly are these standards, and how, as you guys are designing devices, do you accommodate them? So I think that the biggest key is every device has got some sort of communication in, and more of them have wireless communication. Everybody wants to be part of this Internet of Things world. So with that, I think that the key piece is really following standards organizations. And one of the standards organizations, which Freescale has been very tied out with, is the Continua Health Alliance. And this is a nonprofit open industry organization comprised of both healthcare and technology companies joining together in collaboration to improve the overall quality of personal health care. And in addition to that, they are going to be lowering the cost of health care because it's taking a lot of the clinical functions today and moving them home. Another key piece is just preventive health care. So I'll talk a little bit about some of the standards that Continua has adopted, but they were one of the first to put together a personal healthcare device protocol for USB. They've done the same for Bluetooth and the same for Zigbee. So really they are trying to define protocols within these already IEEE standards specifically for healthcare devices. I think another one that's really going to be very important, much more for the clinical side of the Internet of Things use case, is the West Health Institute. So they're actually exploring the means of enabling and accelerating interoperability within the devices through the acceptance and implementation of standard communication protocols. So essentially, within these protocols, putting a communication layer that allows this to quickly and easily populate EMRs and really, solves the problem of having all devices playing nice together. So I mentioned West earlier. They're a great organization, and I highly recommend reaching out to them and learning more about what they're doing in terms of defining standards in this marketplace. So the next question is, what are these standards? And I'm going to start out with some of the low power wireless. So this would be essentially edge node to a data aggregator, and we call this the personal area network. So the personal area network really dominated by things like Bluetooth, Bluetooth low energy. You also do have Zigbee playing in this space as well, more or less along the lines of just the standard IEEE 802.15.4 protocol. And then you have some other networks like the recently defined IEEE 802.15.6, the body area network, and also 802.15.4J, another body area network. So you can see there are quite a few different protocols put into play here. My vision through talking to customers as well as spending a lot of time with market research and other analysts is right now Bluetooth Low Energy has a lot of steam behind it in this personal area wireless network. The fact it's in all smart mobile devices really says it's going to drive a ton of volume, not only in the consumer area, but I think also in the clinical healthcare area as they get continually pushed for lower and lower cost. When you get into the local area network, that's really where I think the topic of discussion today is Wi-Fi, and that's really where Wi-Fi excels. It has a really strong implementation base, specifically within the clinical healthcare market, and with that, almost every device within a hospital is going to have some form of connectivity. And I would say if there was one that they were going to choose, it would be Wi-Fi, specifically for the local area network. And then lastly, some of the others, you do have cellular, and that may be something, as I mentioned, going back to one of the earlier charts, that could be used as a backhaul, specifically to directly to the cloud. If you did not want to make these kind of multiple hops in terms of a Bluetooth low energy radio talking to a data aggregator and then Wi-Fi up to a more server-based system, there are some products out there that are going directly from the sensor to the cloud. Overall, that tends to be somewhat expensive. But in some cases, for a personal healthcare device, it may make sense. But I think more from a structured healthcare perspective, you are going to see essentially kind of the Internet of Things laid out, as I mentioned here, in the end sensor node, low power wireless to a data aggregation device, and then Wi-Fi or a LAN connectivity back to the cloud specifically. So with that said, I want to talk a little bit about what are the microprocessors and microcontrollers specifically used in these applications. And I think one that's really taken hold for Freescale and really dominating a lot in the industrial market as well as specifically in the clinical healthcare is the i.MX portfolio of parts. So it really is a scalable multi-core platform that ranges from single-core devices up to quad-core devices. And with these are really your multimedia processors. I mean, they're really focused on a robust ecosystem, very high performance graphics, high performance audio. So if you're looking at next generation patient monitors, next generation infusion pumps, anything with a touch screen, all of these devices are being very widely adopted. And with that, you're going to have some wireless connectivity to them, and that's really where it brings in my two partners, Mentor Graphics as well as Silex. So just to give you an idea of a block diagram of these parts, I want to go over some of the key features. I mentioned we do have a scalable portfolio, so software and pin compatible products ranging from a single core device all the way up to a quad core device. So some of the key features here, these do have a multi-level memory system. They have smart speed technology, which really allows you to drive the lowest power possible out of these parts. You have the option for dynamic voltage and frequency scaling. I mentioned all the multimedia pieces of this puzzle. So the fact you have a multi-level cache system, a Neon media processor engine, a multi-standard hardware video codec, 2 autonomous independent image processing units. So really a lot of key features specifically for multimedia. And with that, you also have very powerful graphics acceleration. So if you're looking for a very rich user interface, high-performing part, along with a wide range of connectivity options, this is really a great platform for you to take a look at. Looking at actually how this plays in the patient monitoring example I mentioned, I mean, this is going to be the main CPU in your patient monitor. And around that, you're going to have things like our partner solution in order to implement and really make this a useful functional device, having the Nucleus real-time operating system on board with all of the drivers needed specifically for creating a very highly connected embedded device. So the guys from Mentor are going to talk a little bit about how they're actually implementing Wi-Fi in a clinical environment and how they actually do that on our i.MX 6 processor. And then the other piece is just the wireless communication. And I mentioned that our partners Silex are going to talk a little bit about their Wi-Fi modules and exactly how they implement that in a patient monitor example using the i.MX 6 processor. So with no further ado, I will turn it over to Silex to give you a little bit more information on their product offering. Thanks.
Hi, my name's Andy Ross, standing in for Keith Sugawara. I'm the Field Applications Engineer for the Embedded Wireless product line at Silex Technology America. In this section of the webinar, I will discuss best practices to successfully implement Wi-Fi for your medical device. Silex Technology is headquartered in Kyoto, Japan, with offices in the United States, Germany, and China. Previously a publicly traded company, Silex Technology is now 100% owned by Murata Machinery, a world leader in machine tool technology and automated material handling systems. Silex Technology has provided wireless connectivity solutions for medical device manufacturers for more than 10 years. For any medical device, from patient monitor to infusion pump to glucose meter, manufacturers choose Silex Technology when it absolutely must connect. Our secure Wi-Fi solutions transform medical devices into reliable wireless machines that deliver a completely connected, always-on experience. Medical device connectivity has many unique requirements beyond those demanded by the typical wireless customer. The Wi-Fi silicon suppliers typically focus their attention and energy on the requirements of high-volume consumer applications. As a medical device manufacturer, how can you implement a Wi-Fi solution that addresses your specific needs? During the design and implementation process, you will find that there are a number of technologies sourced from different suppliers that all need to work together. At times, issues will come up where it's difficult to pinpoint where the problem resides. In order to minimize time to market and to effectively troubleshoot issues, make sure that your Wi-Fi supplier is connected. The underlying technology of any Wi-Fi solution is the Wi-Fi radio itself. For best performance and reliability, choose a solution that comes from a silicon provider that has an industry leadership position in Wi-Fi. Make sure that the silicon provider is financially stable to ensure long-term supply. And finally, understand product roadmaps to support next-generation standards like 802.11ac as a way to assess continued commitment to the Wi-Fi market. Silex technology uses the Qualcomm Atheros Wi-Fi silicon to create easy-to-implement solutions. Because Silex is a Qualcomm Atheros Authorized Design Center, we have access to Qualcomm Atheros training and support that is available to only a handful of companies in the world. Freescale Semiconductor is also a key member of the Silex technology ecosystem. Silex Technology is a Freescale proven partner and the only manufacturer of Freescale recommended Wi-Fi connectivity solutions for i.MX 6-based products. Freescale proven partners are recognized by their knowledge and experience to help Freescale customers create and implement total system solutions. As a proven partner, Silex Technology is among a select set of companies that participate in advanced product collaboration with Freescale. For more information on our Freescale i.MX 6 Wi-Fi connectivity solutions, please go to www.silexamerica.com/Freescale. Mentor Graphics and Silex Technology have also worked together on several projects for medical device manufacturers. One important element for your Wi-Fi implementation is a driver and security supplicant that is specific to the combination of the Wi-Fi radio and the embedded real-time operating system being used. Mentor Graphics has developed a radio driver and security supplicant for the Silex Technology Wi-Fi hardware, which will significantly reduce your engineering development and time to market. Now that you've confirmed that your Wi-Fi supplier is connected, let's look at other Wi-Fi requirements that are important to medical device manufacturers. Dual band support for both the 2.4 and 5 GHz spectrum is an important feature for medical device Wi-Fi implementations. The 5 GHz band support was first introduced in the IEEE 802.11a 1999 amendment to the 802.11 specification. It's seen widespread worldwide implementation, particularly within corporate workspace. 802.11n radios support either single band, that's 2.4 GHz, or dual band 2.4 and 5 GHz implementations. Using the 5 GHz band provides a significant advantage, as the 2.4 band is heavily used to the point of being crowded. Degradation caused by such conflicts results in frequently dropped connections and degradation of service. The increased number of usable channels in the 5 GHz spectrum and the near absence of other interfering systems gives dual band implementations significant aggregate bandwidth and reliability advantages. The radio chipset's built-in roaming is very simplistic and is designed primarily for high-volume laptop and cell phone applications. While this is fine for the office or your local coffee shop, medical devices often transmit critical data such as ECG waveforms while the patient is in transit. The medical device manufacturer needs a solution that handles access point roaming seamlessly without data loss caused by wireless connectivity problems. Be sure to understand the roaming performance of the Wi-Fi solution you are considering, along with the underlying algorithms used to make the roaming decisions. Because portable medical devices are battery-powered, low power consumption is an important consideration. But what is the specific requirement? In general, the lower the power, the better. That being said, a typical minimum expectation is that the device can be used for a complete 12-hour shift without needing to be recharged. The specific wireless power requirements are guided by the battery and power demand of the medical device itself. While power consumption is a very complex topic, some high-level considerations include the following. Select a radio with an SDIO interface. It's energy efficient and is the interface of choice for battery-powered applications like smartphones, e-readers, and tablets. Next, compare the radio specifications for transmit and receive current consumption in both the 2.4 and 5 GHz bands. And finally, Look for advanced power management features that can dynamically and rapidly put your Wi-Fi solution in and out of very low power sleep modes. Radio chipsets are designed for high-volume consumer applications, which often have a product life cycle of only a few years in order to take advantage of the newest technology. Moore's law, which states that computing power doubles every 2 years, is the driving force for rapid product obsolescence. On the other hand, medical device manufacturers have long design cycles because patient safety is at stake. As a result, the typical medical device manufacturer prefers to source technology that can be available from 5 to 10 years. What can the medical device manufacturer do to solve this problem? In addition to checking with your supplier on the expected availability of the Wi-Fi module, you should also consider an implementation that allows for easier transition to new technology. For example, while a SIP or surface mount module implemented on the product PCBA may be most cost effective, any obsolescence will result in a PCBA redesign. Alternatively, an option card solution that is connector based will allow you to move to next generation wireless solution without impacting your device PCBA. Finally, in most cases, your supplier will not have control over the chipset availability, but that doesn't mean it cannot offer programs to extend the availability of the product. Find out what your supplier has done in the past and will do for you in the future. Because of the long-term supply relationship required to support an extended product life cycle combined with the need for assurance of on-time delivery of high-quality products, medical device manufacturers often have suppliers of critical components undergo a thorough vendor qualification process. This typically includes a multi-day factory audit to ensure that appropriate quality control systems are in place. Confirming that your supplier currently supplies multiple medical device manufacturers will give you confidence in their ability to meet the quality standards expected from your organization. Silex technology provides you with a number of hardware options based on the Qualcomm Atheros AR6003 Wi-Fi chipset. The SX SD CAN is ideal for systems that have an existing SDIO slot. The SX SD MAN is the recommended solution for most customers. It is modular certified and can be attached to your device via a board-to-board connector, or it can be surface mounted directly onto your device PCBA. The SX SD PAN is a SIP that is ideal for high volume applications. It adds RF design complexity, but has the lowest cost and the smallest size. The process to release a product with Wi-Fi can be complicated, so it's important to understand the support services that your Wi-Fi supplier will provide. Personnel assigned and supplier policy may be different during the various stages of implementation, so be sure to clarify expectations during evaluation, integration, and post-launch. It is also important to assess your supplier's ability to provide support. The key question is whether they have access to the radio firmware. If your supplier does not have radio firmware source code, they will not be able to resolve problems without the Wi-Fi silicon provider's involvement. If this is the situation, make sure you understand what response times you can expect. To download our white paper titled Medical Grade Wi-Fi, and to learn more about how to design and develop reliable and secure wireless medical devices, please visit www.silexamerica.com/medical-device-networking. At Silex Technology, we build on more than 40 years of hardware and software connectivity know-how and intellectual property, custom design development experience, and manufacturing capabilities, with relentless attention to quality, exclusive access to Qualcomm Atheros expertise, and strategic partnerships with leading real-time operating system and semiconductor providers. We are the global leader in reliable Wi-Fi connectivity. Thank you for your time today. We look forward to helping you successfully launch your Wi-Fi embedded product. If you have any additional questions or you would like to discuss your specific application, please contact us at the information shown here. We would welcome your call. Presenting next will be Rejmaniak from Mentor Graphics.
This section of the presentation addresses the advantages of using the Nucleus RTOS on the Freescale i.MX processing platform, taking advantage of Silex connectivity options in the medical device market. The goal is to have the audience understand the features and options available to them, addressing the most common issues in medical device design. The topics we'll address are the key aspects of devices in the medical community. The user interface is responsible for the customer perception of a product. Its ability to perform its intended function will depend on user accessibility. Just as important, the interface will also have a major impact on the decision to purchase the product by the end user. Connectivity is now critical to almost every modern electronic device. The connectivity requirements in the medical field are even more demanding than in a typical commercial environment. In this scenario, security is the first requirement for wireless connections. It is closely followed by the ability to adapt to a wide range of connection options. The final key to the puzzle is the successful implementation of a design that has all the required features. In the medical environment, reliability is paramount and must be provided by software vendor as an intrinsic assumption across its entire product offerings. The two major aspects of the user interface that confront developers is the ability to provide a scalable interface that can span a wide number of products, and the ease in which the interface supports the operator's activities. The ease of use imperative is continually placing pressure on the device designer to provide a complex, intuitive interface. At the same time, cost considerations are driving the design towards a far more simple approach. Device developers will see this pressure shift back and forth and need an adaptive software platform to respond to each device's requirements. The Nucleus RTOS provides a level of abstraction that allows designers to accept user input and provide feedback across the wide variety of hardware solutions. At the low end, dedicated input and simple output interfaces, such as hard buttons and serial character displays, are the most economical approach. As product complexity grows, support for graphical output becomes more common, and built-in operating support for software graphics and a hardware GPU is required. For the latest state-of-the-art devices, fully interactive displays that operate with the same fluidity as a smartphone can be expected. In these environments, the support of the Inflection and Qt graphic development tools by Nucleus allows the designer to interactively design intuitive interfaces for their product. As time progresses, users of all electronic products come to expect the same type of interaction that they experience in their everyday lives. As system complexity increases, the need for dynamic, intuitive interfaces becomes necessary for users to successfully navigate the features of a given product. These two forces will drive all markets to provide intelligent interfaces that are centered around ease of use. Users no longer find it acceptable to refer to a user's manual, which tend to become large and unwieldy as products become more sophisticated. The Nucleus RTOS platform provides all the tools to design the touchscreens that will become more common in future devices. Different devices require different levels of connectivity. However, all modern devices are trending towards ever-increasing connectivity options. Connectivity has demonstrated two vulnerabilities. One is security, the other is fast obsolescence. The liability of a poorly implemented security solution is unacceptable to vendors and users alike. The ability to adapt to continuously changing physical layers, protocols, and standards is necessary for long-term product survival. The Nucleus suite of device drivers, protocol layers, and middleware options seamlessly provides application developers with the most current and highest levels of security available today. Complete support for secure web server attachment, wireless security supplicant, secure socket layers, and full 128-bit encryption are included with the Nucleus RTOS distribution. Add to this the dynamic support of wireless transmission devices that provide security offload and hardware. This allows the application developer to concentrate on the value-added layer of software development, all the while knowing that security is already handled by the environment. Connection flexibility is a never-ending demand that is possibly the most quickly changing aspect of modern device design. As this slide shows, the variety of wireless connection methods have trade-offs between speed and range, above and beyond the additional dimension of cost. Not only do the current offerings provide a wide field that potentially must be supported, but future methods of connection are always in development. This wide array of connection methodologies require not only a range of device drivers, but also the addition of protocol layers and middleware suites to meet their specifications. The Nucleus RTOS abstracts these connection methods for the current as well as future offerings. The strength of the implementation will ultimately determine the success of a product. There is a long list of important considerations that are under the hood and not visible in the product brochure, but determine if the device will actually meet expectations after deployment. Power management is critical in battery-powered implementations, but is also important across the board for all modern devices. Within medical applications, the concept of reliability is the starting point for system design. Even in situations where liability isn't an issue, the entire industry is accustomed to systems that coexist with devices that are in a high liability situation. Such devices set the standard for all products. The Nucleus RTOS is differentiated from all other RTOS products by the inclusion of sophisticated power management within the core of the operating system. Applications can dynamically control peripheral power modes as well as switching operating frequency and voltage as supported by the underlying hardware. This support is accessible through an API layer to allow the developer to easily modify these operational characteristics on the fly. Using this feature, battery life can be extended to 10 times what we reasonably expected without power management. And a portable medical device currently under development using Nucleus on a Freescale i.MX processor with Silex wireless support, the customer has achieved their requirement of running 24 hours on a pair of AA batteries. In applications that aren't limited by batteries, this can still result in a 90% decrease in the average heat dissipation, and the corresponding additional flexibility in reducing the thermal constraints on packaging. As mentioned previously, reliability is the cornerstone of the medical device industry. The Nucleus RTOS has shipped over 3 billion units since its inception in 1993. This long-term and widely distributed installed base has provided extensive product stability and reliability. Nucleus is enabled in a wide range of medical devices by a large spectrum of customers and has never failed to achieve medical certification. The latest version of Nucleus has introduced software isolation supported by the MMU, or Memory Protection Unit hardware. Until recently, this type of protection was only available on large processor architectures. With the proliferation of memory protection on modern microcontrollers, Nucleus now supports this feature across a far larger range of architectures. Memory protection provides isolation of the kernel, drivers, and middleware from application code. It also provides isolation between application modules that can be comprised of tasks, libraries, or a combination of both. In summary, the Nucleus RTOS running on the Freescale i.MX family and using the Silex wireless connection options provides all the building blocks necessary for medical device developers to start the design at the application level. Thus, they can focus on the aspect of development that differentiates their product from their competitors. There is no need to design, test, and debug low-level but critical system components. The questions I've gotten so far typically are concerning the security and the security methods for Nucleus in order to allow access. And they seem to be tending towards what are the credentials for login and et cetera for sending the data. Lately, can two or more users connect with the same credentials? Under the normal situation, the under normal situation, access of multiple systems, multiple users under the same password are usually prohibited from the high-level software allowing that type of access. However, once you get above the authorization level of the protocol itself and decide at the machine level, that would be up to the application. So under the WPA supplicant, you would be able to, all the vendors would have the same password. So everybody connecting into the wireless would have the same wireless access password. However, to get into upper level protocols, secure socket layers, etc., that would be administered by the application as far as what's going to allow that protocol to accept. We also have questions here. How is it important to have an RTOS artifacts that are certified? We are actually, Nucleus is in the process of becoming certified for a number of different medical, military, and other type of high liability and applications. So right now we are in the certifications for several of this. Nothing is going to be certified in this particular year. However, our operating system has been certified in applications that meet all the different requirements. And as far as accessing 256 bits, right now the protocols themselves are supporting 128-bit. If the protocol allows a 256-bit encryption, it is possible for us to expand our software to support those additional encryption methods. However, we cannot expand encryption beyond what is specified in a particular protocol stack. And as far as how much does it cost, the order of magnitude of basic development kit, including an SDX, we actually have a wide range of systems depending on whether you want to just do a turnkey system online. It's possible to go to our website, mentor.com, and go through the embedded software link, and we have simple turnkey downloads for microcontrollers from various vendors, and obviously including Freescale, that allows you to download for a few $1,000s a complete development kit that lets you bring up and run on a microcontroller. For larger systems, we'd have to contact our sales organization to authorize licensing for multiple seats and multiple users. As far as the actual price, that all volume driven, so I don't have any actual prices to discuss right here. And questions are coming in pretty fast here. Issue is been addressed. Consider 256-bit encryption, etc. Any customer-driven request for additional encryption, more sophisticated, can just be brought to our attention, and we'll respond. Anything that is possible. Our understanding of the different encryption is that moving to larger and larger encryption just depends on the underlying protocol supporting it and any hardware limitations we would have. But there should be no particular method that would stop us from providing any level of encryption you need. And Andrew, do you want to discuss the Silex question with the Qualcomm technology?
Certainly, Rich. The question is, regarding Silex technology. If Silex is leveraging Qualcomm technology, can you elaborate on the value that Silex adds? There are multiple layers of value. If I just touch quickly on some of them, the discussion could be a fairly long one. But first of all, at the hardware level, we obviously leverage reference designs from QCA. However, we understand the reliability and the performance requirements, and also additional feature requirements that the embedded world requires. So although we base our designs around reference designs, our designs are actually Silex specific and include the experiences that we have had in both the digital and RF design environment. The next level is in terms of software support, obviously multiple components in the software solution, from the supplicant and driver that Rich was talking about through to radio firmware support in terms of inside of the radio. Silex is actually a Qualcomm development center. What this means for, first of all, Mentor and then subsequently their customer base is that we have access to radio firmware source code. And we have experience and a significant number of development hours involved in improving the overall performance of that radio firmware. Falls into two buckets mainly. One, our ability to respond to bug fixes. Often the demands of the applications in the embedded world far exceed performance expectations in the office world or even the consumer world. I think I touched on in the presentation something like, for instance, roaming performance. The embedded world would perceive a roaming performance in consumer world to be a bug, inability to maintain a connection as a patient, for instance, was rolling down a corridor at approximately 3 to 4 miles an hour. It's unlikely a standard roaming algorithm would be able to maintain connectivity and not lose data as it was moving down that corridor. Silex spends significant amount of time making sure that those M2M specific applications and performance demands are improved inside the radio firmware. These are things that are predominantly handled inside the radio firmware. Secondly, we have the ability to actually add features to the radio that would not normally be considered or supported by Qualcomm. An example of that is we have included antenna diversity in the 6003 product line. This is something that as a feature is not available from Qualcomm, is not part of the reference design. So there is many layers and significant advantages. And finally, in terms of support for the customers, we are focused on the M2M world and I've spent a lot of time and a lot of effort, specifically in the medical vertical market. Our responsiveness, our focus is in that space, not necessarily the same focus that you would see from QCA. So significant amount of effort and resources are applied to make sure that you as a customer get dealt with quickly, that a solution is provided for your specific problem, something that you could not guarantee from QCA, obviously based around business levels and stuff like that.
Okay, well, thank you very much for joining. We appreciate everybody's time and all the effort you put into to make this available on your schedule. We hope that Freescale, Silex, and Mentor have gotten together to prove to you that we can provide you with a completely unified solution where you don't have to try to juggle multiple vendors on your own, and we will work together to give you a fully operating platform. Thanks for your time.